as a challenge, I decided to make an extension method that was similar to the 2ARGB method of the color class, except it returned only the red, green, blue values. And I had to do a bit of byte reordering. I went ahead and dissected and compared both of the integers byte structuring, and I found a way to reorder them so that I can effectively create an extension method that simply converts the ARGB int to an RGB int. So the method itself is going to be an extension method of the color, and then within the color I'm just going to get the ARGB values of the color. So 2ARGB. Then we're going to take this ARGB value and convert it to our RGB integer that we want to use with the custom colors array, because that's all it's good for. So I'll show you the byte ordering. I'm going to create a table. This table is going to end up being a bit unproportionate. Okay, I'm going to label the elements that represent the byte elements in the integer. The top row is going to represent the integer that is returned from the 2ARGB method that we want to convert. I'm not actually going to show you the code. You can probably do it yourself, no problem. And our bottom row is going to represent the integer that is returned from the 2RGB method, which is the extension method that we want to define ourselves. Okay, so unfortunately for us, the byte ordering of 2ARGB is going to be BGRA, and for some odd reason the byte ordering of the custom colors int is going to be RGB, and then there's nothing here. And that is just going to make things a lot harder. If I had things my way, I would have the byte ordering of the custom colors int BGR, like it is up here, actually be the exact same thing, except the alpha information would just be discarded. The integer array could be processed and all the alpha information could be discarded if present, but it's not like that. It's quite a bit different. And so all we have to do is reorder the byte elements so that we get our new integer. And I'm using the bit converter class to convert to and from the integer. You can probably find a way to use bitwise operators to reverse this set of elements here and then just discard the alpha information. I'm not too familiar with that, so I just used the bit converter class and a byte array. So let's take a look of where the elements go. So the element R, we're going to start with R. R in this integer goes from element number 2 to element number 1. And then G is going to stay the same. And then B is just going to go from 0 to 2. And then we don't need to do anything with A, we'll just leave 3 as is. The reason the byte ordering is reversed could be because Microsoft doesn't want you to programmatically add your own colors. They just kind of want you to save the user's defined colors and load them. Could possibly be why.